we're going to talk about the trigonometric functions, and we're going to do this based on what's called the unit circle approach. But first, let's introduce the 6 trigonometric functions. The first one, the name of the function is the sine function. Now, given a real number, we find the sine of a real number. And so let's assume the real number is t. T is a real number. So the sine function is just that, is a function. You know, kind of like the square root function. We could say find the square root of 4. Well, here we're finding the sine of t. The second, I don't know that it's first and second, but another trigonometric function is called the cosine function. And we represent that function with cos. So we find the cosine of some number t. Another one is the tangent function. And we indicate the tangent function with tan. So we find the tangent of some real number t. And we have the cotangent function. Okay. Cotangent function we illustrate or recognize with the letter COT, cotangent of some value t. And then we have what's called the secant function. And to indicate the secant function, we use SEC, the secant of t. And lastly, but not leastly, we have the cosecant function. By the way, you see these are in pairs, sine and cosine, tangent and cotangent, secant and cosecant. I've written those in co-function pairs. The co you see of sine. Anyway, and the way we recognize cosecant is CSC, cosecant of some number t. Now we're using what's called, we're going to define these in terms of what's called the unit circle approach. Okay, approach. So before we go further, what is the unit circle? Okay, the unit circle is a circle with center at the origin and with a radius of 1. And that's really where it gets the idea of the name circle. Unit circle, meaning the radius is 1 unit. So center at the origin with radius 1. And so, of course, if we were illustrating that, just a rough sketch, then since the radius is 1, this would be out where x is 1. This would be up here where y is 1. This would be over here where x is -1. And this would be where y is -1, if that's the x-axis and the y-axis. Now, the equation of that circle is very important to us. And we learned at some other time earlier in this semester that if we know the center of the circle, then the equation of the circle is x subtract the x value of the center squared plus y subtract the y value of the center squared. And since the origin is the center, then the x value of the center 0 and the y value of the center 0 is equal to the radius squared. And so this simplifies to x squared plus y squared is equal to 1. That's the equation of the unit circle, and we will use that over and over and over again. Now, the next thing we have to do to determine how to calculate the sine, cosine, and so on of some real number t, we have to introduce the concept of trigonometric points. And so what this boils down to, for each particular real number t, there's a position on the unit circle called a trigonometric point. And it's from that position on the circle, that point that is on the circle, that we calculate and define each of these values. So let's go to the next page and continue. Okay, so for trigonometric points, for each real number, okay, for each real number, t, there is a point on the unit circle. And that point is called the trigonometric point. The trigonometric point for t. Okay. Now, if t is a, so let's do this first. Let's draw a unit circle. So here's the y-axis. Here is the x-axis. Okay. And this position, which, remember, this is a unit circle. Oh, I haven't drawn the circle, have I? I'm sorry. Okay. Here's my unit circle. And of course, unit circle means it's centered at the origin, and it has a radius of 1. Well, if it has a radius of 1, this particular point has coordinates 1, 0. Okay? And that's always our starting point. Okay, now we've got some real number t. Let's assume t is greater than 0. So t is a number greater than 0. So what we do is we draw, if t is greater than 0, we draw part of a real number line. Let's think of it as being vertical, okay? And we measure t units off on this particular number line, okay? And suppose this is where t is on that number line. Now what we do with that number line is we wrap it, if t is 0, we wrap it counterclockwise around the circle. And so as we start wrapping it around the circle, you see these marks are going to come here where this particular point is going to end up right here. Okay? There's where this, so all we've really done is we've measured t units along the circle. That's what we've actually accomplished. Now let's suppose the coordinates of this point are x, y. Let's suppose the coordinates of this point are x, y. That point is the trigonometric point for the real number t. Now, at that point, we could draw a line from the origin to that point, and of course, a line out here to our starting position. And when we do that, then we would create an angle, and that angle we would call maybe theta in this case. Okay, that's theta. It's kind of small there. Now, on the other hand, okay, we're going to use this information in just a moment to define each of those trigonometric functions. On the other hand, if our t was a negative number, well, let's get set up again here. We've got a xy coordinate system. Here's the y-axis. Here's the x-axis. Draw my unit circle. Okay. Now, this position is always the starting point. And of course, since this is a unit circle, once again, because the radius is 1, this point is the point 1, 0. Okay, and that's where we start. Now remember, our t value is negative this time. So we have a t value that's a negative number. Well, if our t value is a negative number, then we wrap in the opposite direction. So we draw our real number line like this. And then we mark off t units. Okay, suppose this is where t is, if we measure t units along this real number line. So there's where we are with t units. Now, we wrap this real number line in a clockwise direction. And so what's going to happen is this point is going to end up on the circle. In other words, all we're saying that's really going on is we're measuring along the circle t units. That's really what we're doing, measuring along the circle t units. But it puts us this position. And that's the trigonometric point. Let's say it has coordinates x and y. That's the trigonometric point for the real number t. Now, at that point, we can draw from the center to that point. And of course, we can draw from the center to our starting point. And so we've created an angle, and along the x-axis is our starting point, as our initial side. As we draw an angle, we'll draw to this terminal side. So here we would have the angle theta. Okay, just as an example. Now, here's how we define each of these functions. The sine of the real number t, whether t is positive or negative, we find out where that is on the unit circle. See, the trigonometric point. Where is it on the unit circle? Well, the sine of t is the y value of the trigonometric point. So the sine of t is the second coordinate of the associated point on the unit circle. The cosine of t is the first coordinate of the trigonometric point. The tangent of t. Now, there's a couple of ways we can think of the tangent of t. Okay, the tangent of t is the second coordinate of the trigonometric point divided by the first coordinate of the trigonometric point. And you can see then that would actually be the same thing as saying the sine of t, since that's the y value, divided by the cosine of t, since that is the x value. I kind of got myself scrunched up a bit here. That's not unusual for me, is it? Okay, well, the cosine of t, well, we go to the trigonometric point, and we've got an x and a y value for that point. The cosine of t is the x value of that point divided by the y value of that point. So we see that in terms of the previous two functions, the x value is the cosine of t, and the y value is the sine of t. So this is another way for us to remember it. In fact, we need to know this, and we need to know this anyway, so we might as well remember how to calculate the tangent of t and cotangent of t, my bad. This is cotangent of t. Okay, well, what do we have next? The secant of t. The secant of t is actually defined as, in this case, it's going to seem backwards the way I wrote it, but it's defined as 1 divided by the first coordinate of the trigonometric point. So in this case, it's 1 over x. Now, another way for us to have written that, since x is the same as cosine of t, then we could say the secant of t is 1 over the cosine of t. Now, likewise over here, the cosecant of t is 1 divided by the second coordinate of the trigonometric point, y. And since y is the same thing as the sine of t, we could have written this as 1 divided by, instead of saying y, we could have said the sine of t. Well, I can't emphasize enough, this is one of the first important tasks, ultra important task, is memorizing each of those values, okay? Memorizing what this says to do. Now, based on that, we can do some calculations. So the first task we're assigned with here is to find the, and I really should say the exact values, okay, find the value of each of the trig functions, sine of t, cosine of t, tangent of t, and so on, if the trigonometric point associated with this number t, we don't know what the number is, but this trigonometric point is the point negative 1/2 comma square root of 3 over 2. So that point is actually on the unit circle. That's the assumption. Otherwise, we wouldn't be asking the question. Now, let's just verify this, by the way. Now, this isn't asked of us in this problem, but remember, the equation of the unit circle is x squared plus y squared is equal to 1. So that means if this point is actually on that circle, that x and y value make the equation true. Well, if x is negative 1/2, and y is the square root of 3 over 2, then when we square each of those and add them together, we should get 1. And that's really the big question. And we're assuming that that's the case, but let's see that it is. When we square negative 1/2, that's negative 1/2 times negative 1/2, which is positive, and 1/2 times 1/2 is 1/4. So that's what we get when we square negative 1/2 plus. Now, when we square the square root of 3 over 2, okay, we square the square root of 3, and we also square the 2. Well, when we square the 2, of course, we get a 4. And when we square the square root of 3, we get a 3, don't we? When we square a square root, we get the radicand. So when we square the square root of 3 over 2, we get 3 over 4. And the question is that in fact equal to 1? And we can see 1/4 plus 3/4, of course, is 4/4, and that in fact is 1, which verifies for us. We're not going to be asked to do this, but it verifies that that point actually is on the unit circle, doesn't it? Okay. Now, not that we need this next diagram to complete the problem. We don't really need it. But it's important for us to understand what these relationships are. So I'm going to draw a diagram before we calculate each of these. So I've drawn a unit circle. Okay, now we've got some value t, some real number t. And when we lay that t out along the circle, remember all we're really doing is measuring along the circle t units. So when we calculate these 2 units, we start here and we lay out, we measure along the circle because we're going to assume t is positive here. We're assuming that. We lay it out and it stops us over here at this point. Okay? And what we're told is the coordinates of that point. And we're told the coordinates are negative 1/2, comma, the square root of 3 over 2. They're the coordinates of that point. Okay, and that makes a little bit of sense here as we see this. That looks like that's about where x is negative 1/2, doesn't it? And if we come over here, well, the square root of 3 over 2 is actually about 0.85. And you know, remember this is up here where y is 1, and so that's very reasonable about where that point would be. Now remember, this is the measurement t units we did along here. See, we measured out t units along the circle, and it's whatever t units is, and it's stopped at this point. And that's what we were told is the coordinates of that point. Okay, so given that information, the sine of t, remember, is the y value of the trigonometric point. And so in this case, that y value is the number, the square root of 3 over 2. So that's all there is to it. Well, we were also asked to calculate the cosine of t. Well, the cosine of t is the x value of the trigonometric point. And we look over at that point, and the x value is negative 1/2. Remember, it's the x value of the trigonometric point. And so, oh yes, then that x value is negative 1/2, and so the cosine of this number t, which we haven't been told what it is, but we know the cosine of it is negative 1/2. So what else were we supposed to find? Oh, we're supposed to find the tangent of t. Now remember how the tangent of t is defined. We can either think of it as the sine of t divided by the cosine of t. That's the same thing as saying the y value of the trigonometric point divided by the x value of the trigonometric point. So all we need to do is make that calculation. Well, the y value of the trigonometric point is the square root of 3 divided by 2. And the x value of the trigonometric point is the fraction -1 divided by 2. Well, we have to be a little bit careful here. Let's come down here to finish this. When we divide by a fraction, see, we're dividing by -1/2, then what we end up really doing, don't we, is that we multiply the numerator by the reciprocal of our divisor. And the reciprocal of -1/2 is -2/1. Now, we're going to have a positive times a negative, okay? Positive fraction times a negative fraction, which is going to result in a negative fraction, isn't it? And in this case, we're going to see that the 2's are going to cancel, and so we'll just have square root of 3/1, or in this case, negative square root of 3, as that simplifies. Okay, let's see what else we were asked to do. Oh, we're asked to calculate the cotangent of t. The cotangent of t. Well, we can remember that the cotangent of t is the cosine of t divided by the sine of t, and we need to remember that since that's really the same thing as the x-coordinate of the trig point divided by the y-coordinate of the trig point. So I'm going to just extend this to the right because I'm running out of space. Now the x-coordinate of the trig point is the fraction -1/2. That's the first coordinate, isn't it? And the second coordinate, which is y, is what we're dividing by. The second coordinate is the square root of 3/2. So in this case, like last time, we actually need to multiply by the reciprocal of the divisor. So we take the -1/2 and multiply by the reciprocal of the square root of 3/2, which is 2 over the square root of 3. Now, once again, we're going to get a negative result. But the 2's are going to cancel this time, and so we'll have -1 over the square root of 3. Now we've got another problem. And the problem is that this is not rationalized. We don't leave a square root of 3 in the denominator, so we multiply by the square root of 3 over the square root of 3 so that we will not be left with a square root in the denominator. So it's still a negative fraction, and 1 times the square root of 3 for the numerator, but when we multiply square root of 3 and square root of 3 in the denominator, we just get 3. So in this case, we get negative square root of 3/3 as the cotangent of t. Okay, then what do we have next? Oh, how about the secant of t? So we've got to practice on memorizing these. That's the issue here. And then manipulating. Well, the secant of t was defined as 1 over the first coordinate of the trig point. Or another way we saw that is 1 over the cosine of t. But no matter how we decide to write it down, the cosine of t or the first coordinate of the trig point, that's 1 divided by, and that first coordinate of that point is -1/2. So we go through the same process we've gone through before, but this time we'll say 1 times the reciprocal of -1/2. That's 1 times -2/1, which is -2. And then the last trig function we're supposed to calculate is the cosecant of t. And remember we said, oh, well, that's the same as 1 over sine of t. Or, since the sine of t is the second coordinate of the trig point, this is 1 divided by that second coordinate is the square root of 3/2. And so this one's not quite as easy to do in our head, so we'll take what we're dividing into, 1, and multiply it by the reciprocal of what we're dividing by. Well, the reciprocal of square root of 3 over 2 is 2 over the square root of 3. And now we see, of course, that that is not in that's not in a rationalized form, so we'll have to multiply numerator and denominator by the square root of 3. And in this case, the numerator will become 2 times the square root of 3, and the denominator, square root of 3 times square root of 3, is just 3. And so now we've calculated, we don't know t, but we know the trig point. We know where t leaves us on the unit circle, and so all we really need to know is that first and second coordinate to calculate all these.